From the Penn Libraries.
Sciences. Our fourth presenter is Jeffery Savin, who's a professor of chemistry, and his classes have been working with us at the Weigel Information Commons for several years now. His course was actually the very first science course where we helped with video projects, and we actually learned a good bit of chemistry along the way. So I'm very glad to turn the podium over to Jeffery Savin.
Okay, so what I'm going to talk about today is a specific project. Not broadly about use of technology in the classroom, but a specific project. The genesis for this project actually came out of attending one of these sessions with regard to how I might be able to use technology, media, in particular video, in the context of this project. So with regard to the problem, with regard to teaching biological chemistry, so this is a course that basically the only prerequisite is general chemistry. Many students take organic chemistry as a co-requisite at the same time, but they come in with a relatively sort of just a fundamental knowledge of chemistry. And so one of the problems is the intense complexity of biochemistry and how it's usually presented in textbooks and in a lot of courses. So like in this diagram right here, we can see that there's, basically there's a lot of stuff going on, and it's a compact way to represent a lot of information, but not necessarily to teach it. All right. Another is that one, particularly from a chemistry perspective, which is there are a variety of different biochemistry courses and different flavors across the campus, but from a chemistry perspective, we're kind of interested in the molecular aspects. And so we'd like to understand something about structures and the structures of molecules. And if we represent those in a two-dimensional rendering, like in a textbook, all right, or here projected on screen, a lot of times it's difficult to discern what the issue is, right, or what the key components are. Like in this case, a rendering of the breast cancer drug tamoxifen bound to its target, the estrogen receptor. Right? So there's a lot of complex information. So can we develop ways so students can interact with structures and with complex information and also show their facility and show their fluency? All right? So with regard to the course, I already mentioned that it's an introduction to biological chemistry. It's sort of at the sophomore level, although it has sophomores through seniors in the course. Some of the seniors are people in other, for example, in engineering, sometimes in Wharton. A lot of people looking to fulfill pre-med requirements, particularly now as medical schools and the MCAT are moving towards requiring more biochemistry. Another problem, I would say, is biochemistry textbooks, right? They tend to be super thick and dense with figures like the ones I just showed you, right? And so then students get really kind of overwhelmed with regard to what do I need to know, what do I need to understand with regard to what I can take away from this course. So in this course, we have on the order to start, on the order of 75 or more students. I use the plus because it's usually capped at 75, but if people request to be added in the room, we'll accommodate that. We do that. We usually lose a few, like in most courses, but it's a pretty big course. All right? And we have one teaching assistant. All right, so that means that we're kind of limited with regard to the amount of sort of instructor interaction we can have per student. So how do we deal with that? All right, so we still have exams. We still have other types of assignments associated with the course. All right, but there was one component that I wanted to try to include, and that was a video project associated with the course. And that's been done for 2 years now. I think we'll try to do it again in the spring of 2015 as well. And so that's what I'm going to talk about and describe in the rest of the talk today. So the ideas with the video project are multifold. One is to build a fluency with regard to the material. Can I actually use the material to explain something or to understand a particular phenomenon or a particular event or a particular type of experiment? All right? And also develop a sense of agency or ownership of the material. All right? To include an aspect of creativity and troubleshooting, because a lot of times people go through, you can go through a whole sequence of science courses and not actually have been that creative. The science, doing research actually involves a lot of creativity, a lot of troubleshooting, and that's not always presented or trained for when we take just standard courses where we learn how to memorize material and how to solve problem sets. And basically to provide a vehicle for students to pursue a particular interest in biochemistry. A lot of them come into the course, they're super excited about the course, they want to, there are reasons they're interested, they want to understand how drugs work, they want to understand fundamental aspects of genetics. And so it gives them a tool or a vehicle or a project with which they can explore that. And then also experience, since it's scientific, of course, with regard to written presentation of material. So certainly writing is important in a wide variety of courses, and particularly in the sciences, but also with regard to how to present and how to understand things visually, right? Like some of the figures I just showed. So one thing that the video provides that I think is harder to do in a 5 or 10 or 20 page paper is to talk about things in a structural, temporal, and quantitative way. By structure, I just mean structures of molecules. How are things arranged in space? How is the structure of this particular protein or this particular small molecule relative to these other ones? How does that fit in the larger context of the structure of the cell? Temporal, if we have a sequence of events that has to happen in a particular time, this happens first, then this happens, and the other thing happens. Oftentimes, that's very easy to describe and very direct in a video format. And quantitative, with regard to the presentation of, basically of plots and other types of material that might be easy to present. So, the other thing I wanted to introduce with regard to this project is certain aspects of science and the scientific community. All right, so one, these are 3 components I think are particularly important. One is the compact, clear, non-vague presentation of material. All right, that's why science is complex, because we want to be non-vague. Another is peer review, and I'll talk about that more, because that's a key component of not just science, but academics, and also a vehicle to interact with other scientists, and I'll talk about more what that means. All right, so with regard to describing the assignment, all right, students get to choose a topic of their choice. All right, basically that has to get vetted by the instructors, but to winnow it down and make sure it's defined well enough. Usually, what we focus or encourage the students to do is to present, a particular thesis or a particular theme or a particular topic, and then to support that. And it doesn't have to be support that with material that they generate in the laboratory. It can be taken from another paper or something like that. A lot of students still fall back into just being very descriptive about the project, and here's a particular event, and here's how it happens. So one thing that was crucial or key is the Weigel Information Commons. All right, so Anu and the group there were essential with regard to helping the students learn how to make these videos and how to put material together. All right, so what we did was we set up a few sessions where students would learn how various aspects of video editing software, and also there'd be a variety of different office hours that were offered as well. Students could come by and troubleshoot problems that they're having with videos. And so one key thing that after meeting with Anu, she suggested is that, and her team suggested, was that we have a timeline, a series of deadlines that students complete as they complete the project. All right, so one is that basically they present a topic that includes also references to primary literature. We talk about what primary literature means versus reviews. And then they draft a transcript. We usually don't review that too closely. It's more just sort of keep them online or keep them on pace to finish the project. And then finally, upload a final video and the transcript of the video. And what they do is usually upload that to YouTube and provide a link to the YouTube site. So each one of the students has a Google account and a YouTube account, and then we provide links to the videos posted there. And then just after those are posted and made available, we also open those up for peer review. All right. So with regard to the guidelines, sort of what's expected with regard to the video. All right. So one, probably the most important thing is do you effectively present some central idea, and is that supported? All right. So that's true, I think, of a wide variety of different topics, whether you write them or whether you make a video. So that sort of in order, these are the ones that carry weight with regard to the assessment of the video. One, the presentation of quantitative and structural information. That's certainly important in the physical sciences. And then features that are unique to video to explain or present information. That doesn't have to be, fancy Pixar-like renderings and things like that, but that can be, do I show a three-dimensional object from multiple perspectives and rotate it? Do I provide an animation that's particularly illustrative? And then lastly, any sort of technical aspects that are unique to video. And those are the sort of the detailed stuff, the aspects with regard to rendering and things like that. And of course, it has to have the appropriate mechanics that we might associate with the paper. Is there bibliography? Do they appropriately cite people and cite sources and things like that? Okay, so what I have here is I have a little montage of snippets from a few of the different videos. So one thing to keep in mind is that a lot of students put things in context. So we're only having about 10 seconds or so with regard to each video, so not everything's in context. The first element of the video will be on alpha-synuclein. Alpha-synuclein is a protein that's particularly important for Parkinson's disease. And a lot of students tend to choose sort of health-related things. Let's see, anything else I want to mention there? Yeah, I think, okay. I should also mention that we've done it twice. We've done it 2 years. So in the first year, it was kind of a mashup. We allowed students to generate images and also just to pull videos down off the web and sort of stitch them all together. All right, in the second year, what we thought would be better, particularly since the students had learned to use software to generate images in the first half of the course, is to do a lot of generation of their own animations and their own images and their own renderings of molecules. With regard to evaluations of the course, it's pretty flat. All right, so there's a set of students that think this is spectacular and a really fun thing to do, and there's a set that thinks it's awful and a horrible waste of time. All right, so we're still trying to sort of negotiate that or figure out whether things want to happen. how we want to direct that. The other thing I wanted to mention is that, one thing, is with regard to the assessment, it's kind of a big time commitment with regard to viewing all these videos. There's a peer assessment component that I didn't really go into details, but we upload through Google Form. Students review each other's videos, and that we were able to provide extensive feedback on each video and provide a peer review report. And students get all the experiences of peer review, including, reviews they don't agree with, all right? And so I think that's a particularly good aspect. But I would say the most spectacular aspect of this project is when they send the videos or make the videos accessible to the authors that they use to generate the videos with. And I didn't really know what to expect the first time we did that. I didn't know if the students would get any feedback, if they get any sort of response. But they get a tremendous amount of feedback, all right? They get emails back. The people are super excited that people are making videos about their work. A lot of times they ask, can I put this on my group's webpage? Will you be in Boston? Can you come meet with my group and show this video? So in that respect, I think it's kind of unique in that, or kind of an exciting aspect with regard to students can go from, I don't want to say nothing, but basically sort of a general chemistry level, learn enough, and have an opportunity to actually show that they understand material well enough and invested the time to make something that now provides a vehicle that they can exchange and provide a touchstone with leading scientists in the field. And so I think that would be harder to achieve if students just sent sort of a 5-page attachment, this is the paper I wrote for this course, and emailed it to some particular scientist. Okay, so I'll leave it there.